Hello everyone, you are welcome back to another interesting question. We are asked to calculate the area of this cycle here. We can see this figure is a semicircle. The length of this line segment is 6 meters. That of this is 24 meters. This segment also has its length to be 6 meters. This point is the center of the circle. So how can we solve this? How can we calculate the area of the circle? It is very simple. Formula for calculating the area of the circle is pi r squared. Pi is a constant which is 3.14. R is the radius. Here there is a circle and a semicircle. Each will have its unique radius. We let radius of cycle equal to r and radius of semicircle be s. So area of cycle now equal to 3.14 r squared. So what is the value of r? We don't know. Okay, come here. This point, if you recall, is the center of this cycle. Let the point be O, this P, this Q, and this R. Say this V. We can see this line segments start from the center O to this point on the circumference. Therefore, it is a radius of the circle, which is R. The same is here. It starts from the center to the circumference. So it is also a radius R. Now if you look at this line AC, it is a tangent to the circle at this point. If we draw the radius to the point of contact, from the circle theory, there is a rule that the tangent of a circle is perpendicular to its radius through point of contact. That is, this tangent here is perpendicular to the radius, so this angle is a right angle. Here, if you look, this angle and this angle are formed by two straight lines intersecting. That is, they are vertically opposite angles. Vertically opposite angles are congruent, so the two angles are congruent. If we let this be A, this must also be A. Come here, draw a line that connects this point A and this B. From this semicircle, we know this side here is its diameter. So since it subtends to this point on the arc an angle, the angle is an angle of a semicircle, which is a right angle. Let's compare this triangle and this triangle. Both are right angle triangle and both have an angle A. That is, they are similar. So if we take the ratio of their sides, this side facing the right angle divided by this side must be equal to this side also facing the right angle divided by this side. Say Z. So 24 over 6 equal to Y over Z. Here 24 divided by 6 is 4. So 4 equal to Y over Z. Multiply both sides by Z. Here Z cancels Z. While here 4 times Z is 4Z. So Y equal to 4Z. That is, this side is 4Z in terms of Z. Let's focus now on this triangle. It is a right angle triangle. We can use the Pythagorean theorem. So it will be 4Z all squared equal to R squared plus Z squared. 4Z all squared is 4Z times 4Z, which is 16Z squared. Subtract Z squared from both sides of the equation. Here Z squared minus Z squared is 0, while here 16Z squared minus Z squared is 15Z squared. So R squared equal to 15Z squared. Take the square root of both sides. Here square root of R squared is R, while here square root of 15z squared is 0 root 15. So r equal to 0 root 15. Keep it aside. Look at this line AD. It is also a tangent at this point V. Based on the rule we mentioned earlier, if we draw the radius to the point of contact, the angle formed will be a right angle. Look at this quadrilateral. We have a pair of equal adjacent sides, that is this and this. Both sides are at right angle with the other two sides. The only type of quadrilateral that has this property is a kite. So therefore, this quadrilateral is a kite-shaped quadrilateral. So since it is a kite, this side and this side, since they are adjacent, they'll also be congruent. Since we have this side to be divided into this 24 and this z, the length of this side will also be 24 plus z, which is z plus 24. Now another property of a kite is that the long diagonal bisect the angle it touches. So this angle and this angle are bisected. If we assume the size of this angle to be b, this must also be b. And if this is c, this must also be c. Let's now look at this triangle ADP. This line AO bisects this angle of 8. Therefore, it is an angle bisector of the triangle. There is the angle bisector theorem, which states that the angle bisector of a triangle divides the sides it intersects into two segments which are in the same proportion as the other two sides. So by this rule, this segment is in the same proportion with this as this side is to this. So we write it out. R plus x over 4z equal to line AD over 24. This 24 is 4 times 6. This 4 cancels this 4. So it is R plus x all over z equal to line AD over 6. Keep it aside. Come here. Draw a line that connects this point and this point. We know since this angle is subtended by this line AD, which is the diameter of the circle, the angle is an angle of a semicircle, which is a right angle. Now look at this triangle. It is a right angle triangle. This side is perpendicular to this, and this line, which is connecting the two other sides of the triangle, is also perpendicular to it. That means it is parallel to this side. We can use the Thales theorem, which states that when a line is drawn to one side of a triangle intersecting the two other sides at distinct points, the line divides the two sides in the same ratio. So by this rule, this line OD divided by this line PO must be equal to this line CO divided by this line PQ. So R plus x all over 4z equal to over z. This z will cancel this z. So R plus x all over 4 equal to 6. Multiply both sides by 4. Here 4 cancels 4, while here 6 times 4 is 24. So R plus x equal to 24. Come here, replace this R plus x with 24. So 24 over z equal to line AD over 6. Multiply both sides by 6. Here 6 cancels 6. While here, since 24 is same as 4 times 6, 6 times 6 is 36. 4 is same as 2 times 2. 2 times 6 is 72. And 2 times 6 is also 72. 72 plus 72 is 144. So line AD equal to 144 over z. That is, the length of this line AD is 144 over z. But you have this segment to be z plus 24. Therefore, this will be 144 over z minus into bracket z plus 24. Minus into bracket z plus 24 is minus z minus 24. So it is 144 over z minus 24. Now look at this triangle. Applying the Pythagorean theorem, since this is the hypotenuse, the square of the sum of this r and this x must be equal to the sum of the squares of this r, and that's 144 over z minus 24. So r plus x all squared equal to r squared plus 144 over z minus 24 all squared. This r plus x, we have its value here to be 24. Substitute it here. 24 squared is 576. This r, we have its value here to be 0 root 15. Substitute it here. 0 root 15 all squared is 15z squared. So 576 equal to 15z squared plus into bracket 144 over z minus 24 all squared. Here 144 over z minus 24, simplifying into a single fraction, is 144 minus z squared minus 24z all over z. 144 minus z squared minus 24z all over z all squared is 144 minus z squared minus 24z all squared all over z squared. If you square this bracket and collect the like terms, it is z raised to the power 4 plus 48z raised to the power 3 plus 288z squared minus 6912z plus 20,736. We can include this in the fraction by multiplying it by this z squared. 15z squared times z squared is 15z raised to the power 4. 15z raised to the power 4 plus z raised to the power 4 is 16z raised to the power 4. This z squared will multiply by this, and if you take it to the right, this 288z squared minus 576z squared is minus 288z squared. So 16z raised to the power 4 plus 48z raised to the power 3 minus 288z squared minus 6912z plus 20,736 equal to 0. If you divide through by 16, you'll get z raised to the power 4 plus 3z cubed minus 18z squared minus 432z plus 1296 equal to 0. This is a quadratic equation. We solved it in a different video. The link is in the description. But in the other video, I used x instead of z. The answers we got are 3, 6, 6 plus 6i, and minus 6i. Which of these is our answer? These contain 6i, which is an imaginary number. Cannot be our answer. It is either 3 or 6. And as for 6, if you substitute it here, 4 times 6 is 24. That is, the hypotenuse of this triangle is equal to that of this, which is impossible because this triangle is larger than this. So therefore, z equal to 3 is the right answer. Substitute it here, r equal to 3 times root 15. Square both sides. Here, 3 times root 15 all squared is 9 times 15. And 9 times 15 is 135. So r squared equal to 135. Substitute it here. 3.14 times 135 is 423.9. So area of cycle equal to 423.9 meters squared. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.